Morning, everybody. Can you hear me and see the screen?
Yes, sir.
Yes, sir. All right. So we're just gonna practice a couple of questions. We're gonna practice a couple of these um, circuit theory and trigonometry questions. About an hour, short session, not too long. All right. Quick revision, so you guys can see that what we're doing in class, as I always say, is what you see on exam papers. Because that's what it's about. Being able to do the questions on exam paper. All right. That's what we're preparing for. I think I see what the issue is with the tablet. I think I need to clean it up. All right. So on the screen is a number 9 on May 2024 exam. Right. It's a circle theory question, as you can see. It says V, X, Y, and Z lie on the circumference of a circle shown below. Center is O, and the diameter is VY. So this is a diameter right here. That's a diameter. All right. It says angle VXZ is 62 degrees. That's this angle right here is 62 degrees. And angle XVY is 18. That's the angle right here is 18 right here. All right. And then now they give us some angles there. A down here, B up here, C right here, D right here, E right here. I guess we're gonna have to find those angles. So remember the 7 rules, guys. Center rule. Angle at center is twice angle at circumference. Diameter rule. Angle subtended by diameter is 90 degrees. Same segment rule. Angles in the same segment are equal. Cyclic quadrilateral rule. Opposite angles in a cyclic quadrilateral are supplementary. Tangent and radius rule. Angle between a tangent and a radius is 90 degrees. Two tangents rule. Only two tangents can be drawn to a circle from a single external point. Two tangents will be equal in length. The two tangents and the two radii together form a cyclic quadrilateral. And then now the tangent and chord rule. Angle between a tangent and a chord is equal to the angle subtended by the chord. Then all the other rules that we know for trigonometry also apply. So for example, total angle in a triangle is 180 degrees. Total angle on a straight line is 180 degrees. Angles that are vertically opposite, like angles across from a Z, from an X, sorry, like these two angles will always be equal. They are called vertically opposite angles. Then we have Z angles and U angles when we have parallel lines. Like we have, if these are two parallel lines and we connect them, the tip of one to the tail of the other, we form alternate angles. So these two angles will be equal at alternate angles. And if we join both of them at the tail like this, then these two angles will always add up to 180 degrees. We call those co-interior angles. Or we could have joined them at the nose as well, up here. Again, these two angles will add up to 180 degrees. And don't have to be square like that, because it could have been that our parallel lines are like this, and I could have joined them down here at the tail like that. And these two angles again still add up to 180 degrees, co-interior angles. All right. And again, if I join them here from the nose of one to the tail of one, then I'm forming alternate Z angles there. All right. So anything like that you have to be familiar with. And those are the angles. Also, when we have parallel lines, we can also have what we call corresponding angles. So for example, if this line is parallel to this line, all right, and they are joined by this transversal line, right, that crosses two parallel lines, then we are forming what we call corresponding angles. These are things that we have to know. So for example, this angle and this angle, they are equal because they are forming the same angle between the transversal line and the parallel line. So those are what we call corresponding angles. They are equal. Like this one would be equal to that one, for example. All right. So those are the things that we're looking for. One thing I wanted to remember about a circle is that this triangle inside here, for example, is called a sector triangle, it is always isosceles because this is a radius and this is a radius. The two of them equal in length. And so the two angles opposite the two radii will also be equal. So the angle opposite this one, which is here, is equal to the angle opposite this one, which is here. That's an isosceles triangle. Remember also that in an isosceles triangle, you only really need to know one angle. If you know one angle in an isosceles triangle, you can find the other two. Because remember, if you have two of them already equal, then any one angle you know in an isosceles triangle, you are able to find the other two angles. Alright? So that's always an isosceles triangle. Alright? Any angle in a sector, any triangle formed from a center, like this one, as we just did, is isosceles. Alright? In that diagram, that would be an isosceles triangle. The two other angles in there are equal. Alright, so those are some of the main things I've just gone over. I've just said you would have had all those things in the notes in class. It's a matter of knowing those things. You don't want to have to be figuring out those things in an exam. Figuring out stuff take time. So you want to be able to know your stuff and just apply and go. Alright, what do they want us to do? They say state a theorem that satisfies the value of each of the following angles. So what they're basically saying that what theory, what rule is used to show that angle B is equal to 62. Let's look at it. So see the 62 right here. And this is the angle B. That same segment, you know, I want to know the same segment rule because look, this 62 degrees, right? Or let's put it this way. This B degrees, if you find the chord that is subtending it by coming back along the sides, forming the angle until you reach the circumference. That's from here and here. So that angle is subtended from those 2 points. So it's either subtended by this chord, or you could say it is subtended by this arc. That's B angle. Now, if you look at it, the same chord, let's say focus on the chord. The same chord is subtending this angle of 62 up here. And these two angles are in the same segment of this chord. This is the minor segment down here, and this is the major segment over here. These two angles are subtended by the same chord, and they are in the same segment. So that is the same segment rule. Those two angles are equal because they are subtended by the same chord or subtended by the same arc, and they are in the same segment. So it's the same segment rule. And all we need to do is write that rule. They are equal because they are angles subtended in the same segment by the same chord. Same segment rule. So we can say angles in the same segment are equal. I think if you stop there, they'll give you the marks. They'll give it a mark. There's only one mark. That's what they really want to see. Same segment. That's what the main thing that they want to see. But to extend the statement, we can say when subtended by the same chord, angles in the same segment are equal when subtended by the same chord or arc. Alright, remember all the theory that we're talking about, the 7 rules that we use, are when the angles are subtended by an arc or subtended by a chord. So it's understood that we're talking about when they are subtended by the same arc or subtended by the same chord. We're talking about same arc and same chord rules. Alright? That's the reason why this angle is 62 as well. So let's put on the diagram. Now we know it is 62. Let's put it up here. So this angle B is actually 62 degrees. Then they're asking us now, why is angle C 124? And that angle C is clearly right here. It's at the center. That angle C is at the center. And again, if you find what is subtending it at the center, it's the same chord right here. Come back until you reach the circumference. Again, it is subtending from these 2 points. This is a chord that is subtending that angle. Or if you could say this is an arc that is subtending that angle at the center. Now the same chord or arc is subtending the 62 degrees at the circumference up here. So when two angles are subtended by the same chord or arc, and one is at the center and one is at the circumference, the one at the center is twice, that's the center rule. Angle at center is twice the one at the circumference. So the angle C is going to be 2 times 62 degrees. 2 times 62 degrees, and that is how we get the 124 degrees. That's why angle C is 124 right here. Center rule. So if you want to write angle at center is twice angle at circumference. Simple as that. Angle at center is twice angle at circumference. And that's when they are subtended. When subtended by the same chord or arc. Same chord or the same arc. Everybody good so far? Everybody okay so far? Alright, so this angle at the center is 124. So let's put it on the diagram now. This angle at the center now is 124 degrees. Alright, let's put it right here at the center. This is 124 degrees. That one. Alright, which other angle do I want now? I don't want us to find out that now. Let's see. Let's say, explain why this angle is 90 degrees. That's the angle OVW. Let's see why it is 90 degrees. OVW. Angle OVW. OVW. That's this angle right here. But that's the angle between a tangent and a radius. That's a tangent and radius rule. Angle between a tangent and a radius is 90 degrees at the point of contact. Angle between a tangent and a radius is 90 degrees. So that is the rule, tangent and radius rule. Right? So that's why that angle is 90 degrees right here. Alright, simple as that. So that's tangent and radius rule. So let's write that. Angle between tangent and radius is 90 degrees. I need to get a new device, you know, where the pen comes with it, because this is not my handwriting really. This I'm using a device that does not come with a stylus, so I have to start that out. Alright, that is that. Next part now says you must find the angles A, D, and E. Show all working where appropriate. So this is not asking for the reasons, right? This one. Maybe the working out is gonna be, maybe the reason is gonna be the working out. But they say find angle A, D, and E. So let's look at the diagram now. So I guess this one now, we have already done 3 questions. We have to give reasons really. And they help us by telling us what the answer was. I know they want us to just get those 3 angles. I guess it's 1 mark each. Alright? And say show working where appropriate. So look at angle A first. Alright, oh by the way, we just calculated that this angle here is 90 degrees. Let's put it down. This angle is 90 degrees here. That's 90. That's a symbol for 90 degrees. Now the one angle A. Now if you look at it, angle A really is the angle between a tangent and a chord. So now we're looking at the tangent and chord rule. Angle between a tangent and a chord. Now the angle between a tangent and a chord will always be equal to the angle subtended by the chord at the circumference. So since the angle between that tangent and that chord is 28 degrees. The chord is subtending 62 degrees up here at the circumference. So whatever the angle is between the tangent and the chord is equal to the angle subtended by the chord. So those two angles equal. We have to know that rule, that the tangent and chord rule. Whatever angle the chord makes with the tangent, it is the same angle that the chord will subtend at the circumference in the alternate segment of a circle. Sometimes they call it the alternate segment rule. Alright, so that angle is 62 degrees. And I'm just going to write the reason. Since I should show working, the working really is reason. So this angle is 62 degrees. I'm going to write the reason because angle between tangent and chord equals angle subtended by the chord. And it's at the circumference. It's really at the circumference. Now if I leave this, I think I get the marks, you know. But the complete thing is at the circumference. At the circumference. In the alternate segment in the alternate segment. So I think though, if you just write this, just this alone, you get the 1 mark for it. I think that's all they're looking for. Angle between a tangent and a chord equals angle subtended by the chord. Alright, but this is the full thing. Alright, so if you're in doubt, just give them the full thing. But I want you to at least know this part first. At least give them that. At least that. Alright? So that angle is 62 degrees. Then I want angle D next. Let's look at the diagram for what angle D is. Then put on 62 degrees down here in the diagram. Take these out. I'm saying that this angle down here is actually 62 degrees. This angle down here is 62 degrees. Then I want angle D. Angle D. Well, that's fine. Angle D is in this isosceles triangle. Remember that triangle is isosceles, you know, guys. And we know one angle in it. No, we don't have the arc or chord that is subtending angle D, you know. So we couldn't use that method. Because if we come back along this side, we are stopping right here. We don't reach the circumference. And we come back along this side, we reach the circumference. So we don't really have that chord or arc that is subtending angle D. So really and truly, we can't use that method. Right? We can't use that method because we don't have a chord on the diagram or arc on the diagram that is subtending the angle D. So we cannot use that one. We have to go and use the triangle, the fact that it's an angle in the triangle. And these two angles in the triangle will be equal. Those two angles will be equal. So two ways we can find D. We know that the angle between here is 90 degrees, you know. This angle is 90 degrees because the angle between this tangent and this radius. And this part of the 90 degrees is 62. So this remaining piece inside here will be 62, will be 90 degrees minus 62, which will be 28 degrees. So them two angles equal, so it means that the D is also equal to 28 degrees. That's one way. The other way to do it is to say this is an isosceles triangle. Right? This is an isosceles triangle, and these two angles that I'm marking here in this isosceles triangle, they are equal. And so we could say angle D is equal to 180 degrees minus the 124 degrees at the center right here, and then we divide that by 2. Right? I'm sure it's still going to work out to the same 28 degrees. Right? It's going to work out to the same 28 degrees. if we do it that way. Alright, if you can check. I don't know what the tablet doing that time, guys, so I can excuse. I don't know. Maybe I have too many things open on it. So that will give you the same 28 degrees. And because total angle in the isosceles triangle is 180 degrees. Can you hear the pinging, guys, on the device? Can you hear the pinging?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Hold on. It's a notification, you know. The thing is updating. How do I turn off notification on this? Let me see if I can turn off notification. How do I turn it off? How do I turn off the notification on this thing? Notification. It is a notification. It's updating my notifications.
Sir, just turn on the phone.
Huh?
Just turn off phone.
If I turn it off, you won't.
Oh.
I need to turn off notification. Hold on. How do I turn off notification? I don't want to turn off the notification. If I turn off, let me see sound.
You don't notification.
Sound. Okay. I'm not seeing it. Oh, silent. Good. All right. Thanks. All right. Good. I want to turn it off altogether. That's what I want to do. I want to turn it off altogether.
Sir, but we're not here again, sir. Good, sir.
Yeah, but it's slowing up the device still because they keep popping up. It's trying to update. See, already it's off and I don't know why it update, why it doing it. I see these are all the notifications. These are all the apps on the device. All of them off, so I don't understand. See there? All of them off.
Sir, try to keep on advanced.
Oh, so one on. Let me turn this off. Oh, see there, these two on. Oh, that is it. Okay. Alright, good. It's supposed to alright now. Alright, guys, sorry about that. Let's see. Alright. Problem is that this device is tied to my other devices, so that's what is happening. And to go through and just kind of clean it up. Anyway, that's the calculation for D. So we're going to use total angle in the triangle is 180 and get it, right? So the D down here, we could say the D is equal to 180 degrees minus the 124 degrees, they divide by 2. That gives us 28 degrees. And that's because total angle in the isosceles triangle is 180 degrees. Total angle in the, I have to say isosceles triangle is 180 degrees. And that triangle is isosceles. If you want to name the triangle that is isosceles, you could name it here. In this case, it is OZV. Triangle OZV. So you could say triangle OZV. Total angle in triangle. Isosceles triangle OZV is 180 degrees. Right? And the two base angles equal, 28. Next one is angle E. The one next. Angle E. Let's see now. Angle E. Let's see, they want us to now calculate angle E. Let's take these off. So we now know that this angle is 28 right here. It's 28 degrees. And we're asking us for this angle right here. Alright, we're gonna get that angle now. Alright, let's see. So that angle is subtended, is a part of the angle that is subtended by this. We don't have the chord that is subtending this angle E right here, because again this one comes back and stops here. And you cannot go by how the diagram looks either. So you cannot say that this is 90 degrees. You cannot do that. Alright? Can't do that. So what are we gonna use? And we don't have the arc that is subtending it, as I just said. Because we stopped right here. We have not reached it by the circle. So you cannot go for a chord and arc. So I want to go for a triangle, total angle triangle situation or something like that. So I want this angle E. It would have been a part of this triangle here. We don't know this angle, we can assume it is 90. Right? Oh, can I get that one now? Let's see. Alright, so if I focus on this big triangle, I know that this angle is 62 already. If I can know this one, then I'll be nice, which I can know that one. How can I know that one? Because if you look at it, let me erase some of this for you. Look at this big triangle that I'm marking out in red now. Right? This angle is 28, you know. So this is also 28. Right? So putting the 28 right here. Putting the 28 degrees right here. And basically we know these two combined. 28 plus 18, how much is that? 46. It's 46 degrees across there. And then total angle in that red triangle is 180 degrees. Alright, so the sum of all these angles is 180 degrees. Maybe there's an easier way, but I'm just not seeing it right now. These three angles add up to 180 degrees. But this angle is a combination of the 28 and the E. 28 and the E, the combination there. Alright, I think that's the way to do this question. So I would say the 28 degrees plus the E over here plus the 62 degrees plus this 48 degrees down here, 46 degrees down here must equal 108 degrees. And that's the premise on which we're going to find this angle E. Everybody can appreciate that? Everybody good at that?
Yes, sir.
That's how we can find the angle. So we're going to add up all of these three things and subtract them over this side. So the E becomes, right in alpha, the E becomes equal to 180 degrees minus the sum of the 62, 46, and the 28. All of them degrees. Put that out, I have the angle E. Maybe there's an easy way, but I'm not seeing any other way right now. Alright, not seeing another way at this moment. Let's see, we couldn't use tangent and chord because we don't have the chord or arc that is subtending this angle. So you go to triangle when that is the case, or quadrilateral or something like that. Again, we do our quadrilateral either. Alright, so I think this maybe is the best way to do it. So it's 180 degrees minus 62 minus 46 minus 28. I'm getting 44 degrees for the angle E. 44 degrees. Alright, that is that. Alright, so that is it. So that will be the calculation. I'll basically just copy this calculation down here and put it on there. This question don't want really, that will be total angle in that big triangle is equal to 180. That's the approach that I see right now. Alright, that is it. That's what I get. So that's what I got. That's all I got. I want to copy all of this. I want to paste it down here. And so we'll get the angle E. And the reason will be total angle in the triangle is 180 degrees. I could name the triangle, alright? But that is it. They didn't ask for it, but that will be it. So, by the go to that, let's move to this question. But okay, right? Up here.
Yes,
But
sir.
alright? Alright. So I tell you the circle theory question most times come with a bearings question, but this will be a 3 dimensions. This is a sine with cosine, well, not 3 dimensions, sine with cosine. Let's see what it says. Diagram below shows a quadrilateral PQRS formed by joining two triangles PQS and QRS. So we have this triangle and this triangle. None of them are right angle triangle. Right? None of them are right angle triangle. So we cannot use so-called tower in any of them. You have to use the sine rule or the cosine rule in either of them that we're working in. Sine rule or cosine rule. Question says calculate the length of QR, which is this side. So to calculate that side, we're going to work in this triangle over here now. This triangle. To find the QR. And what do we have in this triangle? We have a typical case for the cosine rule. Two sides with an angle between them. So we're going to use cosine rule to find this side over here. Alright? Straightforward. Simple, straightforward. So we're going to write, we're going to say, start like Pythagoras theorem. Remember, starts like Pythagoras theorem. So it's going to be that QR squared will be equal to this side squared plus this side squared. If it was a right angle triangle, 18 squared plus 16 squared. But because it is not a right angle triangle, you cannot use Pythagoras theorem. You have to subtract a piece for the cosine rule. What you subtract? Twice the product of these two sides, 18 and the 16. Times the cosine of the angle between the 18 and the 60, which is 25 degrees. Then instead of leaving the square here to just find the QR, we can square out this side by cancelling that square and square out that side. And then put everything that we have in the calculator to get the length of QR. Do that calculation and we have the length of QR. Let me see if I can bring up the calculator to do it. Do that calculation and we have QR. Let's see if the calculator is here. Here it is. So it will be the square root and put in everything exactly as it appears. 18 squared plus 16 squared minus 2 times 18 times 60. I don't bother put the brackets. Times the cosine of 25. Make sure the calculator is in degrees and you can see the DEG up the top there. Make sure the calculator is in degrees. And the answer is 7.61. 7.61. Give your answer to 3 significant figures when they don't tell you the level of accuracy they want. So I'm going to write 7.61 and it's meters. The meter measure is meters in the diagram. Alright, so this side is 7.61 meters right here. Equals 7.61 meters. In case we need to use it again, put on the diagram. Next part wants us to calculate the bear order. Give us a bearing. Alright, so that's all they gave us so far. And then they gave us a bearing. Alright, let's see what this says. QR part 2. Tell us a bearing. It said the bearing of P from S. So remember now, bearing must be measured at the from position. So it's from S to P. They're giving us a direction from S to P as a bearing of 205 degrees. So remember, bearing is just a direction expressed as an angle clockwise from the north direction. That's what bearing is. So it's from S to P is 205. Let's put on the diagram so we can use it. So they're telling us now from S down to P, the bearing is 205 degrees. So from S to show that 205 degrees, you have to show the north direction, which is this north direction. And then no, this is the direction down to P. The bearing of that direction would be this angle all the way around here. That total angle will be 205 degrees. That's the angle that is 205 degrees. Now part of that total angle is 25 here and the 72 here that we can see on the diagram. So the piece of that angle that is missing right now is this piece right here. That marked in blue. Right? That is the piece that is now missing right now. This red angle is 205 degrees. So that blue angle would be 205 minus these two. But let's see what they want. I guess that is the angle that they want in this question a bit. Let's see what they want. They want the bearing of R from S. So they want from S to R. S down to R. They want the bearing of that direction. S to R. So that bearing must be measured from at S. So from S to R. Let's see on the diagram. See it here, that's what they actually want, this blue angle. from S down to R, they want the bearing of that direction, which will be the same blue angle that I've put there. So it's going to be 205 minus the 72 and the 25. Alright, so that's what it's going to be based on this diagram. So just straight calculation. That blue angle in the diagram will be 205 degrees minus the 72 degrees and the 25 degrees in the diagram. And that will be the answer. If it comes out less than 100, you have to put 0 in front of it, right? So it's 205 minus 72 and minus 25. It's 108 degrees. That's the bearing of S, of R from S. Then I want the bearing now from P to S. The bearing from P to S. I want the bearing in the direction P to S. P to S. What's the bearing in the direction P to S? Remember, bearing is just a direction, remember, guys. P to S. Let's look at the diagram. So this blue angle worked out as what? 108. Just in case we need it. The blue angle here is 108 degrees. The blue. The red is this one over here. Alright. So we want now the bearing of what again? So back on to P to S. P to S. Alright. The bearing from P to S. Direction P to S. That's this one. P back up to S. This way. Alright. Now let me show you something now. P to S. Now, most persons will say, okay, we want the bearing from P to S this way. And they say bearing must be measured at the front position. And it will come down here and put in the north line, like so. And they say that is this angle we want to find, which is true. And then to find that angle, what most persons might do, they say, okay, this angle, find this angle over here first, and put down a different color, maybe in green. They might say, okay, find this angle over here first, which is fine, which is 180 minus the 205, and they would know that these two angles add up to 180 degrees because they are co-interior angles. Alright, and you could get the answer that way. So this angle up here first will be 360 minus 205. I think that's what most persons would do. What I'm gonna do now, 360 minus 205. Because we are taught to say the bearing angle is measured at the front position, right? That's what we teach it in class. But we can also focus that bearing is a direction. It's a bearing of a direction. So we get 155 right here now, right? And then this angle inside, you know, which is the bearing, will be 180 minus 155 because, as I said, these two angles add up to 180. They are co-interior angles. So we know the 180 degrees minus the 155, and we get 25 degrees. Because it's bearing, I have to put a 0 in front. So the answer is 0, 25 degrees. But let me show you another way you could do it. Right? We could focus on the fact that the bearing is a direction. And because I have so many angles, I know so many of the angles around this point, I could actually work out the bearing at that point, you know. Let's see how we do it. Let me take this off. Alright? So we want the bearing right now of this direction. From P to S, going that way. So if I zoom in on the diagram now, watch me carefully now. Or maybe I should use a different color. Use the green or purple. Alright, so put that down in purple. So I want the bearing of this direction, P to S, right? So I said it would be, if I put the north line here, it would be talking about this angle right here. Is the bearing now. Because I have so many angles in this region, I can actually come up here and still get the bearing of that direction by doing what? This direction is still the same if I extend this line straight up here. This direction is still the bearing of P to S. That direction is still the direction P to S. And the bearing angle that I want will be this angle right here. This. And extend this north line up for you. So you can make it a little bit more clear. And extend this north line up. So this is the north line still. So the angle that I want, right, will be this angle right here and put it in green for you. This is still the bearing of that direction. This. So if we can figure out that direction from the information that we have, that was still good to go. Now, how could we figure out that angle, that green angle? It's kind of easy because remember now that everything on the down here, on this purple line from here to here, around this point, is 180 degrees. This down here says 180 degrees. Total angle on a straight line, 180 degrees. And the total angle, the red angle, is 205. So from the north line, come all the way around to here, we said it's 205 degrees. Right? So the angle inside here that we really want is 205 minus this 180. So the bearing angle in here, the bearing of this direction inside here is actually 205 minus 180, which is going to give you the same 25 degrees that we just got down here. Same 25. This angle down here and this angle down here, up here, are the same corresponding angles, the same bearing direction. And again, you have to put the 0 in front of it. So if I'm in the exam room, I'm going to do it this way because it's quicker to get it that way. Why is it quicker? Because I have so many angles around this point that I can use, rather than to come and work down here and have to work out this one and then do another calculation. You see, by just recognizing that, just extending this direction line, this one, I know that this is the angle that we want up here, right? And then use the information that we have to get that angle. Total angle on a straight line down here is 180, so it's 205 minus 180, and that is it. Everybody good with that? Everybody okay?
Sir.
And
Yes, sir.
you put all these markings on the diagram, same way, you know. You put all these markings. If I'm doing the exam, I'm putting all these markings on my diagram. I even put this P to S direction on the diagram, same way. Right? And get the answer much more quickly and go about my business. So that angle that I want down here, right, would be 205 degrees minus 180 degrees. It will work out to 25 degrees, but because it's bearing, they will put 3 digits, they put a 0 in front. And it's 2 marks for that, and I said easy, but I guarantee you, most persons will do it the way that I just showed you. We'll put in this down here and say, okay, the bearing angle is right here. Find this one here as a first calculation that, and then now use total angle there, so it's 180 and subtract. Come back to the same 25. Alright, so we need to understand and use the fact that bearing is the angle of a direction, not just of a line. It's the angle of a direction. Bearing is a direction. Alright, guys, if you can appreciate that, a lot of your questions will be a lot easier to work out. You just feel like some information missing. Let me see what else they want us to do. They must have some other kind. That's it. So they don't ask us to work in this triangle. They have not asked for anything in this triangle as me missing something. Let me see. I feel like I'm missing something. Am I missing a page? This is page 31 and page 32. Weird. Why they bother give us these dimensions in this triangle? I'm not using any of it. Oh, because maybe we could have for this angle as well down here in the triangle. I don't know. And then we don't know if this line is east to west. I don't know. It's weird. Anyway, we use information that we need. Maybe they put all that information to see, to try to trick people or something, but it just seemed kind of weird that they give so much information that we didn't need in the question. Alright, because the question didn't ask us for any distance. Calculate the length of part 1, and this is part 2. Question done. Weird that they give so much information. I didn't want anything else. Anyway, that's what it is. Maybe they intended other things and took some of the questions that they intended to ask off the diagram. I don't know. Or maybe it's a diagram from a question in another exam, but they're asking different things on the same diagram. That's how it is sometimes. Alright, that's 2024. How long now we're going? How long now we're going, guys? That's one question. Let's do at least another one. Right, remember, this is just a revision session now, guys. So I don't like when the Saturday class is too long. People lose interest and all of that. Let's look at 2023. That's what I ask, So just revision for us to practice. And I get a chance to show you a couple things and emphasize a couple things. Alright, in case I'm missing something, you have to always be practicing. Alright, let's look at the ones on this paper. That's what we get to do. So always second question in section 2, we get these bearings, elevation, and so on. Let's look at this one, 2023. This one kind of said similar. Alright, let's look at this one. Alright, so this one gives us this diagram. It says L, M, N, and R are points on the circumference of a circle. So I look at it, I'm seeing a cyclic quadrilateral, see it here? Cyclic quadrilateral. Opposite angles are supplementary in that cyclic quadrilateral, right? It says, center O says PQ is a tangent. So once you have a tangent, you're looking for tangent and radius, tangent and chord. Remember, the angle between a tangent and a radius is 90 degrees. The angle between a tangent and a chord equals the angle subtended by the chord at the circumference in the alternate segment. Then it says angle PRL is 48 degrees. That's what they showed here. And that's the angle between this chord and this tangent right now. So the chord subtend the same angle up here before we even start. Up here. All of this angle is same 48 like this. Before we even start, you know that, right? Tangent and chord, and the angle at the center is 156, and at the center is 156. Remember also that this is an isosceles triangle. These two lengths are the same. These two lengths are the same, and so that is an isosceles triangle. And so these two angles equal, this one and this one. If you know the one at the center, then you're good to go. You can find these two easily if you need, right? And then now angle at center is to angle at circumference. This angle at center is subtended by this chord, or you can say it is subtended by that arc. And the same arc or chord from this point is subtending this angle at circumference. This chord is also subtending one at circumference. The one at center is twice one at circumference. So this angle up here is half of 156. Half of 156. Alright, so you know that already. Alright, anyway, let's answer the questions and let's not preempt the question, but I just want us to be reminded of stuff. Let's continue. So the question says, find the value of each of the following angles, given reasons for each of your answers, and show all working where appropriate. The first angle I want is angle R. Let's see what angle R is. Angle R is this one. Alright, so that's the center rule. Because if you don't know, you can come back until you reach the circumference here. Find what is subtending the angle from the circumference. It is this chord clearly. And the same chord is subtending this angle at the center. 156. Well, the center is twice. So as I said, this angle is going to be half of 156. Because the one at the center is twice. So we can go down there and do that. Angle R is equal to half of 156 degrees, or 156 over 2. What that equal to? That equal to 75 plus 3, that's 78 degrees, right? 78 degrees. Reason, angle at center is twice angle at circumference. Right. If you stop this, you're good. But you could add and say, when subtended by the same chord or arc. Remember, we're doing same arc, same chord. Circuit theory. Our angles are subtended by arcs or subtended by chords. Remember that we're looking for angles obtained by chords or angles obtained by arcs. The rules that we're using are when the angles are obtained by chords or by arcs. Remember that, guys. But I go to that one. I'm gonna center twice.
Yes, sir.
Yes, sir.
Alright. And I put on the diagram that's 78 degrees. So this angle up here is 78 degrees right here. Alright. Now look at the diagram. That's gonna also gonna be 78. Because I want to know. That angle up here is obtained by this chord. And that chord is making an angle of E degrees with the tangent. Whatever the angle is between a tangent and a chord, the chord subtends the same angle at the circumference. So it means that this angle is same as this one, 78 degrees, tangent and chord rule. So I see that already, even without me seeing the question yet. What's the next question? Same thing, angle E. It's equal to 78 degrees. Angle E equals 78 degrees. Same as the one at the R. You can put R if you want. It's equal to angle R, which is equal to 78 degrees. That's because angle between tangent and chord equals angle subtended by the chord. If you want to finish the statement, you can say at the circumference. If you stop right here, you're good enough. If you stop right here, you're good. But let's finish it still. At the circumference. At the circumference. Talking about angle subtended by the chord at the circumference. And it's in the alternate segment. Why is it in the alternate segment? Because remember now, so the chord, this chord divides the circle in this minor segment and this major segment. And this angle you would say is kind of in this segment. The angle that is equal to is the angle subtended by the chord in the other segment over here. Not this segment. Because if we were forming another angle down here, then this angle would not be equal to E. That's why the angle has to be in the alternate segment. So the angle between the tangent and the chord, the angle that the chord subtends at the circumference in the alternate segment. Not this segment where the angle is between the tangent and the chord. It is in the other segment over there. Alright? In the alternate segment. That's what I call it. And then I call it alternate segment rule. In any case, this angle is 78 degrees as well. And this is a knowledge-based topic, guys. You just have to know these things, alright? Don't need to any explanation or whatever. Just know that's how it is. It's a knowledge-based topic for the knowledge profile on your exam. Alright, so let's put on the degree up here, 78 degrees. Then I want angle A. Let's look at what angle A is on the diagram. Angle A, that's this one. Now for that one, that angle is obtained by this chord. Right now, what is the chord doing? I'm not seeing anything else that the chord is doing at this moment. Alright, let's see what else the chord is doing at that moment. But that angle is an angle in this cyclic quadrilateral as well. That angle E is an angle in this cyclic quadrilateral as well. And in the cyclic quadrilateral, these two angles are equal. No, sorry, those two angles are up to 180 degrees. Opposite angles in a cyclic quadrilateral are supplementary. Now, total angle on this straight line is 180 degrees. right? So the angle inside here, where 180 minus the sum of those two, those angles are like they're adjacent to one another on this line through this point. So this angle here completes the 180 degrees. That is the total angle on that straight line. Alright, those adjacent angles. So that angle there will be 180 degrees. Come on, Mr. Shaw. 180 degrees minus the 78 and the 48. Maybe there are other ways to do it, but this way I'm seeing it right now. Alright, and you work that out. So this angle is going to be some of those two, you know, because if these three add up to 180 and these two add up to 180, then this one is going to be the sum of the 48 and the 48 and the 78. But let's work it out step by step, and nobody will see that. So let's get a calculator quick and just subtract these. Alright, it's gonna be what that sum is. So it's gonna be 180 minus the 78 and also minus the 48. If you want brackets, 54 degrees. This is 54 degrees. That angle. And then this angle over here now becomes 180 degrees minus the 54 degrees. Right? So it comes back to the 78. Huh? Yes. Oh, alright. Alright. So that come back to the sum of these two, 48 and 78. So we're gonna subtract again 180. So get 126 degrees. 126 degrees. Maybe there are easier way to do it, but that's the way I'm seeing right now. So first I'm going to say that total angle and straight line is, and I can leave these working out on the paper, right, and put the reason right here. Total angle and straight line is 180 degrees. That's what I'm using over here. Right, so total angle on the straight line is 108 degrees. And then now over here, why do the 180 minus that is because opposite angles in a cyclic quadrilateral, cyclic quad, opposite angles are supplementary. They are supplementary. Supplementary simply means that they add to 180 degrees. It's the premise of this calculation. So the answer is 126. So it is 126 and the reasons are on my diagram. So down here I could just say 126 degrees. And my answers are on the diagram. For the reasons, I could say C diagram. Above. For my reasons, the reasons are on the diagram. I will leave these on the paper. If you're not sure, you can write them again. Alright? It's human beings marking the papers. It is not machine. So you say see the diagram, somebody's just going to come and look at the diagram and see your work right there, and that's fine. Alright, and you can use colored ink just the same as I've done here in the exam. Nobody's going to penalize you for using different colors to highlight your work in the exam. It actually helps with the marking. Alright, not a rocket science or anything. There are rules, yes, but you know, they're not going to kill up anybody for those things. As I said, it's human beings in there marking the papers. Maybe even teachers that you know, right? Same teachers that teach in the school go and mark the exam papers. Alright, so don't be worried about these things. Alright, and that's that. Next part. Okay, so next part now is a bearings question down here. But this question says, the diagram below shows a triangular field LMP on horizontal ground. So this is a triangular field on horizontal ground. As I look at it, I see three sides with no angle. So to find any angle in there, I'm going to have to use a cosine rule. Because the triangle is not a right angle triangle. See? Find angle MLP. That's the angle at L right here. Let's call that angle alpha. I'm just going to put it equal to alpha and put alpha on my diagram right here. So I have to use a cosine rule. Remember, the cosine rule starts out like Pythagoras' theorem, as if this was a 90 degree and this was an hypotenuse. That's how it starts out. It was not, and so I've got to subtract a piece. So you start this cosine rule as you would start Pythagoras' theorem. If this was the hypotenuse and this was the 90 degree, you would have said that the hypotenuse squared, which is PM squared, is equal to the sum of the square of the other two sides in the triangle. If it was a right angle triangle, 150 squared plus 120 squared. Well, it's not a right angle triangle. The angle is not 90 degrees. Actually, a different angle from 90 degrees. I put degrees and this is supposed to be square. And so if I subtract twice the product of these two sides, that's all you have to remember now. 150 and the 120, and then cosine the angle between them, which is alpha that you don't know. Let me take these off now. So cosine, you know that Pythagoras' theorem is actually cosine rule when the angle is 90 degrees, because the cos of 90 is 0, and this part will be gone when the angle is a right angle triangle, and you're left with Pythagoras' theorem. Alright, so in case you don't know, I've said it in class, but I'm saying it again. And that's why we can think of start the cosine rule like what would start Pythagoras' theorem. And what it is now, guys, is that you want to transpose to make this alpha the subject. Alright? Now, with practice, you'll be able to just write out what alpha is. I can look at this and write out what alpha is. What are the steps to transposing? All of this, we know this, I shouldn't call it PM, because we know it's 180, so let me write the 180 here. Instead of PM, we know it's 180, so let me write the 180 here. It's 180, not PM, it's actually 180, we know it's 180. Right, and we're trying to make this a subject. What's gonna happen? I'm gonna take all of this that is negative, bring it over this side, and then take this and bring it over here. So the first step will be that all of this comes on this side and become positive. So because I'm on the device, I can just copy it. Just copy it and put it over here first as a subject. And then now everything here come back. 150 squared plus 120 squared. And then this now comes over this side and becomes minus 180 squared. Minus 180 square. I keep putting degrees, but it's square. And then this part of this expression now is divided under here. Alright? So what I can do, I can just, because I'm on the device, I can take all of this and divide it on this side and then put this division line in there. Okay, I can shift all of this down. And then now, to get the alpha, we take the cos to the minus 1. So again, I can shift this over because I'm on the device and put cos to the minus 1 over here. Cos to the minus 1 and cos is inverse cos of everything. With practice, you'll be able to write from this line to this line in one step as I have it, but I just showed you the steps. And then you put all this in the calculator, now you get alpha. Put all that in the calculator, which you should have the calculator that can put all of that in there one time. So it's cos to the minus 1 of a fraction. On top of the fraction, we have 150 squared plus 120 squared minus 180 squared. And then we're dividing that by, I'm not gonna put the bracket, I'm just gonna write 2 times 150 times 120. Same thing. Calculator give me 82.8, 3 significant figures. When I don't tell you the accuracy that they want, give it to 3 significant figures. 1 degree, one decimal place in case of degrees, angles in degrees. So that's 82.8 degrees is the angle MNP. 82.8 degrees. I'm going to put it there now. 82.8 degrees. That's what that angle is. So the only thing I don't know in this triangle now, right now, are the 2 angles down here. These 2 angles. Any one of them I want, I can use sine rule, because I can use this pair of angle and side opposite each other. Alright? And if I want to find this angle, I'm using this pair. And if I want to find this angle, I'm using that side as the pair. So going forward, sine rule can be used to find these 2 angles, any one of these 2 angles that I want next. Well, let's see what else the question really wants. Let's see. So find that angle. Next part now gives us a bearing. So the bearing of P from L. Let's make sure we get it right. So it's from L to P. It's from L to P. It's L to P bearing. It's 210 degrees. L to P. Let's put on the diagram. L to P. So see L here, talking about the bearing of this direction. It's 210 degrees. The bearing of that direction, guys, is from this north line and from this north direction all the way around to the direction that will take you down to P. That is the angle that they gave us as 210 degrees. Now the angle inside here, so it's 82.8, and that total angle is 210. Then we can know what this angle is in purple by subtracting, and that would be the bearing down to M from L right now. If you should ask, and I bet that's what they're gonna ask. Bet you that's what they're gonna ask. That purple angle that is drawn there is what they're gonna ask. 210 minus 82.8. Let's see the bearing of M from L. I bet you that's what I want. See there, the bearing of M from L. That's how these questions are all the time. Right? If you do a couple of them, you're good to go. The bearing of L from L is simply 210 minus the 82.8 degrees, which works out to be, let me just subtract 210 up here on the screen. It comes out to be 127.2 degrees. But when it's bearing, you only need to give 3 digits to the nearest whole number. So I'm going to write my answer as 127 degrees, 3 digits. That's my answer, 127 degrees in bearings. Alright, I guess if we give the 127.2, they give it a mark, but really and truly, bearings you generally just give 3 digits. Give to the nearest 3 digits. Nearest whole number, 3 digits. That's what they want to give for bearings. So that purple angle is 127.2 degrees, but the bearing answer that I'm giving is 127. Alright, let me put the 127.2 on the diagram here, still in purple. So this purple angle matches this purple writing. This purple angle matches this purple writing, 127.2 degrees. Alright, purple angle matches that purple writing. What else I want us to find? It's to calculate the value of angle NLP and hence find the bearing of L from P. So now I want the bearing from P to L. But the first thing was to find this angle first. Right? So I want the bearing from P to L. Let's see. I want the bearing from P to L. So it's a similar question, you know, like we just did, you know. We just did a question like this. Not too long ago. So now they want the bearing of this direction. And they're telling us to find this angle first. telling us to find this angle first. This one, NLP, telling us to find this angle here first, and hence find this one, which is the bearing. So they're actually forcing us to use that method where I just told you, just showed you that you can actually find the bearing of this direction from P to L by simply extending this line up here. And it is the same direction, P to L, that blue direction. And that bearing will be this angle that I'm going to put on the diagram in green. This angle. And that angle is simply going to be 210. And all around here says 210. And the straight line, the angle on the straight line right here is 180 degrees. So the angle is 30 degrees. 210 minus 180, that's 30 degrees. The answer is 30 degrees, quick and fast, you know. 0 to 30 degrees. I'll put the 0 in front because it's bearing. So this angle is 30 degrees. Right? 210. I'm going to mark it up. This angle that I want right here is 210 degrees minus 180 degrees, which is 30 degrees. So the bearing of from P to L will be 0 to 30 degrees. Right? 0 to 30 degrees. And put it down here. So the answer for this part over here will be 210 minus 180, which is equal to 30 degrees. I'll put the 0 in front. That's the answer for that part. But if you're forced, if you follow their method, because they say find this and hence find that, then now the NLP will be what? It will be this angle over here that I want. This angle over here. Let's put on in blue. NLP will be this angle over here. So the total angle around the certain point is 360 and this portion of it is 210. The remaining angle will be 360 degrees minus 210 degrees, which will be equal to 150 degrees. Then the bearing from P up to L, if you measure it at the front position by putting the north line at the front position here, and that's theoretically how they do it. I put in the north line here. Then this is the direction from P to L. You want the bearing of that direction. So the textbook say is this angle you want. But then these two angles are up to 180. So see, if this is already 150, then down here so it's 30 degrees. Okay, these two are up to 180 and this up here says 150 already. So down here so must be 30 degrees. 180 minus 150 is 30. So the bearing is the same angle here, so that we want 0 to 30 degrees. So you can put the 0 in front of it. 0 to 30 degrees. Let me write it better. So this angle here says 30 degrees, but as a bearing is 0 to 30 degrees. So if they just ask for the angle straight, I prefer to do it this way. But I can calculate it more quicker because there are so many angles around this point that I can use to get it. Alright, you see that's 210 minus 180 and you get the angle that you want. You have less calculations for it. In any case, this is the same answer right here. Alright, so to be 180 degrees. First the angle that I want to be 150. Angle NLP will be 360 minus 210, which will be 150 degrees. And then the bearing that I want will be 180 degrees minus the 150 degrees, which will be 30 degrees. We'll put 0 in front of it. Get 3 digits. That's it. Just stand up. But I write with that.
Yes, sir.
Miss what time is it now? 12:30. Alright. Let's do one more. Let's do one more question. Let's do 2022. Remember now, all these questions I'm doing here now, you guys go have to do them again, you know, in mock exams, you know. So, you know, you're gonna have to do all these questions again. That's in the last of these questions. We'll start to do our mock exams. Alright, close to the exam, we're doing our revision and stuff. you are gonna have to do all these questions over again under exam conditions, right? So I'm just showing you, so you should be familiar and be comfortable by then. But it's good if you can just, redo the questions that I'm doing here today, practice them. If you notice the questions are similar, you don't ask them any different. They'll give you different angles, different values, but they are quite similar. So if you can fully understand and do one, you're on your way to being able to do all of them. And the more them you practice, the more comfortable you get doing them. And the more you see that they are basically asking the same thing over and over again, over and over again. That's what makes this subject easy, because I keep repeating what I ask. Let's see if I have a better 2022. Let's see, I do have a better 2022. I sure I get a better 2022 than this one. I'm not seeing it. Let's see. Alright, let's look at this one now. 2022. I'm gonna do this one and we'll call it a day, alright? Don't want to do too many today. And you can go now and practice them. Let's go and work them over again. Alright, let's look at it. You're gonna see the same kind of thing again. This one says H, J, K, L, and M are points on the circumference of a circle center O. MK is a diameter. That's a diameter. Remember, diameter sub 10 is 90 degrees, right? So right now, diameter is sub 10 in this angle at circumference. So you know right away that this angle over here is 90 degrees. For every star, you know that. What else I say? They said MJ equal JL. So two sides equal. So the lines are meant. Once you see this mark on a line, and you see a mark on another line, means that they're equal in it. Once you see that, it means that this is an isosceles triangle, guys. That's an isosceles triangle. Right? That's an isosceles triangle. With these two sides equal. And so the two angles that are opposite, the two sides are equal. So this angle and the whole of this angle are the same. Alright, and as I give you the information, I remember all of that, those two total angles equal, those two red angles equal in that isosceles triangle. Alright, they don't give you these things for nothing. Alright, oh, there are some parallel lines in it as well. So once you see parallel lines, now you're thinking co-interior angles, what you call U angles. You're thinking alternate angles or Z angles. See, it says MK is parallel to HJ. So let's put it on there now. So these two lines with the arrows on them are parallel. Let's mark them. These two lines parallel. What are they connected with? First, they are connected at the base down here. So it means that these two angles are up to 180. Those are two co-interior angles. These two angles are up to 180 degrees. Co-interior angles. That's one. Alright. They are also joined. Those two red lines, which are parallel, are also joined by this transversal line here. So alternate angles, it means that the angle inside here, which is 38, is equal to the angle over here. That angle is also 38. Right? Those two red lines are also connected at the nose down here with a different color. Those two red parallel lines are also connected down at the nose here. So these two angles now are co-interior. They seem to be angles in that U. Call them U angles. They are co-interior angles. They add up to 180. So these two angles add up to 180 degrees. So you're looking out for those things. They don't give you the parallel lines for nothing. They don't give you the two sides equal here for nothing, because they want to use isosceles triangle. So you're looking to use those things as you go through the question. You're looking to use those things that are coming to play. Expect them to come into play at some point. All right, let's go. Question says, explain, giving a reason why angle HJM is 38 degrees. HJM. HJM. Why is this angle 38 degrees? Yes, alternate angles. Because this line, as we said, let's put on again, it's parallel to this line. And two of them join nose and tail by that blue line, called a transversal line. And so you have alternate angles. Those two angles are alternate angles, or Z angles. So now that alternate angles are equal. Simple. That's the reason why they're equal. Alternate angles. Alright? Alternate Z angles are equal. Alternate because Z angles are equal. The one mark for saying that. Alright? And why is angle MJK 90 degrees? Let's look at it. Angle MJK is 90 degrees. Why? Because it is subtended by a diameter. See it there? Diameter rule. So that blue angle here so is 90 degrees right here. Subtended by a diameter. So that's the reason. Angle subtended by a diameter is 90 degrees. So I'll write that. Alright, so we're gonna say angle subtended by a diameter is 90 degrees. That's it. Angle subtended by a diameter is 90 degrees. Simple as that. One mark for saying that. Alright. Sometimes they say angle in a semicircle is 90 degrees, but same thing. Next part now said determine each of the following, right? And show detail working awareness. But let's put on these two angles that we have found first in case then we need them. Let's put them on. So we just said that all of this angle is 90 degrees between these two sides. 90 degrees between this and this is 90 degrees. This is a piece of it, so this will be 90 minus that if it comes to it. All that is 90 degrees. I also said that the angle down here is 38 degrees. Same as that one, right? Let's put on a diagram in case we need it. So this angle down here, let's put on as 38 degrees. 38 degrees is this angle over here. Alright, put them on as you find them. What else they want us to find now? It says angle MLJ. I give appropriate reason. MLJ. Let's look now. Angle MLJ on the diagram. MLJ. So they're not asking us for this angle. Alright. Now that angle is subtended. If you come back, let's look at what's subtending it first. That angle is subtended. Come back to the circle and go back to the circle on this side. It is subtended from these 2 points by this chord. What else is the chord doing? It's also subtending this angle up here. Same chord. Let me put the chord in a different color. So the chord that is subtending that angle that we want is this one. Right? And that same chord is subtending, but I use a different color. It's subtending this angle up here. So it means that the angle over here is equal to the angle that we want up here. Same segment rule. But this happens to be a right angle triangle. This one. I'm marking out now in red. It's a right angle triangle. Where this angle is 90 degrees. So these two angles are complementary angles. They add up to 90. So if we find this angle, it is the same as this angle. Alright, so that's the premise. And we can find this angle. These two angles add up to 90 degrees. Complementary angle. So this angle over here that I've marked, sorry. This angle down here is actually 90 degrees minus the 38 degrees. Which is 52, 90 minus 30 first is 60, minus 8 is 52 degrees. So this angle is also 52 degrees. We're going to explain that. We're going to say that these two angles equal first. Angle that I want. MLJ is equal to MKG. Same segment. Let's do that. So first we're going to say this angle that we want, MLG, is equal to angle MKG. And then because of same segment, right? This is because they're in the same segment. Same segment. Angles in the same segment are, let's write it out, because angles in the same segment are equal. That's why those two equal right now. Angles in the same segment are equal. Alright, that's the first thing. And then now, what is this angle? This angle is 90 degrees minus 38 degrees, which is the 52 degrees. And for this now, this total angle in the triangle is 180. Right? Total angle in this triangle now, MKJ, is 180 degrees. This angle is already 90, so these two must add up to 90. So you can write total angle in triangle. What is it? Which one? MJK. Total angle in triangle MJK is 180 degrees. And the one at the one in the corner is already 90. So these two must add up to 90. So that is it. What are good at that?
So,
Alright, so that angle is 52 degrees. So let's put them on. Let me clear the diagram and put them on. So you see what I did in that question, guys? Let me show you. We wanted this angle here. Can I see it off the bat? So what you do, go back until you reach the circumference, which is here on one side and here on the other side. Find what is subtending the angle, which is this chord. Look at the processor now, that chord. Look what else the chord is doing. The same chord is subtending this angle here up at the circumference. So you say, okay, same segment. So it means that these two angles, this one and this one, are equal. These two angles now, this one that we want and this one equal. And then now I was able to find this one because I'm now working in this right angle triangle. Alright? By finding this one, I also know this one. Alright, so you see, that's how sometimes you have to go. You're not going to get all the angles straightforward all the time. Alright, so that's the premise. That's how we got that one. So practice these questions, guys. Practice it and follow our process as much as possible. Oh, these two angles are 52 degrees, right? Let's put them on 52 degrees. 52. So this angle here says 52 degrees. And this one is also 52 degrees. Same segment rule. Alright. Next angle I want is angle LJK. Angle LJK. Let's see what that is now. LJK. LJK. So the angle that I want is this angle inside here, so now this one. Alright, let's look at it now. That angle, if you can't see what it is right away, find what is subtending it, a chord or an arc. What you find, you come back along the sides forming the angle till you reach the circumference. Come back. Don't stop here, sir. No. You're coming back until you reach the circumference to see what is subtending the angle. What is subtending that angle is this arc right here. What else is that arc subtending? That same arc is subtending, and put in purple and green for is subtending this angle up here. So. So right now those two angles equal now. So this angle I want is equal to this angle up here. So if we can find this angle up here, then we would know this one down here. So question is, can we find this angle up here? Alright, let's see now. What do we have? Well, we have not used the Z angles yet. Alright, so what we have to use now is the isosceles triangle to find this angle up here. So to find this angle, isosceles triangle. Why is that? Because remember now that this triangle is isosceles that I'm marking out in red. Remember isosceles from the beginning, such that all of this angle is equal to this angle in this isosceles triangle. Now, if this angle is 52 and all that is 52, then this little angle that I want here now, this little piece of angle that I want inside here, mark it in red for you, is going to be 52 degrees minus 38 degrees. That's what it's going to be. But I agree with that?
Yes, sir.
That's
Yes,
50 minus 36. That's what 14. 14 degrees. And so the angle over here that you want is also 14 degrees by same segment rule. This is also 14 degrees. Now there might be other ways to do it, but that's the way I'm seeing right now. Right? Those two angles are subtended by the same arc and the same segment, so they are equal. So the same sort of thing. You have to tell them, say, this angle that I want is equal to this one. And then this one over here is 58 minus 3. So because there are angles in the isosceles triangle. Alright? So that is it. So that angle that I want is 18, is 14 degrees. So we can say this angle that I want down here is actually equal to the angle over there, which is, what is it again? It is this angle here is angle L, is angle LMK, same segment again, angle MLK, angle MLK, and this is because same segment are all, same segment again, same segment. Same like up here, so angles in the same segment are equal. But then this particular angle is equal to 52 degrees minus 38 degrees, which works out to be 14 degrees. And that's because isosceles triangle. That's because they are in the isosceles triangles. Isosceles triangle. Has two equal angles. Alright, and that is it. Right, 52, that this angle is equals all of this. So that's a 52. That's all 52 minus 38. And that isosceles triangle. Alright, I'd advise you to go and do this one over again. Alright, then the last angle I want is now angle JHM. Let's see. Angle JHM next. I like to put on angles that we'll find on the diagram in case we need to use them again. So that's 14 and 14, right? Let's put on the two 14s on the diagram. Because most times, a lot of the time, they need to use them again. So this angle is 14 degrees. Took all the wrong things. I'll leave the arrows and I'll leave the arrows. Let's leave the arrows. Let's leave the arrows on the diagram. So let's take these off. Take these off and leave the arrows. So those two angles are 40. Which one angle do I want now again? Angle what? Angle GHM. 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 Where is that now? GHM. So that's this angle up here that I want now. This angle GHM. No problem. These two angles are opposite angles in a cyclic quadrilateral, right? So the cyclic quadrilateral here, it's very obvious. Draw it out in red. This line, this line, this line, and this line form a quadrilateral with 4 vertices and a circumference. So it is cyclic. So these two opposite angles add up to 180 degrees. They are supplementary. So since this one down here is 52, then the one up here is 180 degrees minus 52 degrees. 180 degrees minus 52 degrees. Which works out to be 180 minus 50 first is 130. Minus 2 more is 128 degrees. Because opposite angles in a cyclic quadrilateral are supplementary. That's the reason. So it's 150 minus. So this angle down here is 150. 180, sorry. Minus 52. Which is 128 degrees. That's because opposite angles in a cyclic quadrilateral are supplementary. Which means that they add to 180 degrees. That is it. Yes, that's that one. All right. Better go do this one. But okay. Go and redo it, please. Go and redo it. I'm sure the paper is in the group. I would have sent this paper in the group before. Search in the group for it. All right. It's a May 2022 exam paper. It's in the group. All right. Let's go now. If you don't have it, you can send it to you. If you don't have it. Next part says no. From a port L, ship R is 250 kilometers. See it here? Ship R from L is 250 kilometers. It's on a bearing of 0.65 degrees. Let's put on this on the diagram. So like you're at L, you have to turn to the right 65 degrees to face the direction, to go in the direction to L. Alright, so the angle that 65 degrees is this angle right here. 65 degrees. I only put 0 on it. The angle is 65 degrees, but the bearing is 0.65 degrees. That angle is 65 degrees. Alright, it says ship T is 180 kilometers from the same L, and that one is on a bearing of 148 degrees. So see here, ship T from here is 180 kilometers, 140 degrees. So bearing of this direction is 148 degrees. That's all of this angle around here is 148. Is a different color? Let's use a different color. Let's use purple. The bearing all the way around here is 148 degrees. That's the bearing of T, direction T, for direction L to T. 148 degrees. Alright? It says this information is illustrated in the diagram below. Well, they didn't put on angles. I'm adding them on now. They only gave the distances. It says complete the diagram by inserting the value of angle RLT. Now, RLT is the angle inside here, which is the difference between those two. The 148 minus the 65, clearly, is that angle, right? Because the whole thing is 148, and the blue piece is 65. So it's 148 minus 65. Which gives us 83 degrees. So the angle inside here, I'm going to put it down in red, is 83 degrees. I must insert it on the diagram. 83 degrees. Am I right? 83 degrees. It's the angle inside here. And we can put the calculation over here. 148 minus 65 is how we get the 83 degrees on that diagram over there. Alright, you can put that on a calculator, on the paper. And then we can use cosine rule to find this side now if I want it. Easy. Right? Because we now have two sides with the angle between them. Cosine rule will find that side. It says calculate RT, the distance between the two shapes. That's cosine rule. Alright, so cosine rule we're going to use. So start like Pythagoras system as usual. Then alright, this side squared, RT squared, is equal to this side squared plus this side squared. 180 squared plus 250 squared. You subtract a piece, you subtract twice. Let me shift this over. You subtract twice to 180 times 250 times the cosine of the angle between them is 83 degrees. And then now instead of having this square, you can square this side to get rid of the square and then square it over all of the right side. And then just put all this in the calculator. And we will have what the RT is equal to. So I'm going to put all of that in the calculator right now. So the square root of 180 squared plus 250 squared minus 2 times 180 times 250 times the cosine of 83. And it's 289. Let's call it 290. Put this 250 properly. Let's call it 290. 3 significant field with 290 kilometers. That's what RT is. The thing is, they want the bearing of T from R. So they want the bearing from R to T. They want the bearing from R to T. Bearing of direction R to T. Alright? I want to bring off the direction R to T. Let's look at the diagram. So what we just found was 290. Let's put on the diagram in case we need it. This is now 290 kilometers this side. 290 kilometers. I want the bearing of what again? R to T, right? R down to T. So I want the bearing of this direction. So clearly now we have to do the bearing right here. Can't get away. So I have to work from this point, bearing down to this direction. Now, when they want the bearing from this point, right, 95% of the time, the angle inside the triangle at this point will play a part in the calculation. So right now, I'm just going to call that angle alpha. So I think this angle will play a part in calculation. I'm looking for this angle to play a part in calculation, which I can find using sine rule. Using these two with these two in the sine rule to find the alpha. Alright, but the bearing that I want, let's put on the bearing that I want. The bearing that I want, let's put it on in purple. It's like at R, the front position R, you have to put a north line. Remember now that this north line, let me just stretch it up through the diagram, through the writing, is parallel to this one. Right? And so that north line is parallel to that one. And so these two angles, this one and this one, are co-interior angles. And put on in blue, the blue ones. This angle right here is co-interior with the 65. So this angle up here will be 180 minus 65. Alright? But the bearing that I really want, excuse me guys, excuse me, the bearing that I really want is this clockwise angle that you have to turn to the right to face that direction. That red angle is what they really want. I'm going to call it theta. Alright, I'm gonna call it angle theta. Now what method let's say I'm using the alpha. So I'm using the alpha. I'm just thinking of another way to do it. If I extend this line down, then this angle inside here will be 65. So it's more, it's just another way because of the Z. So the Z here, up this one, down this way. It should be 65 in here. Alright, so it will be that theta. You know what? Let's do it the way that I say. So this angle is easy to find. It's 180 minus 65 co-interior angles. Let's put it on. This angle up here. These two angles are up to 180 co-interior. Because it's like this line and this line parallel, and the angles in the base of the U. This one and this one are up to 180. So this angle over here will be 180 degrees minus 65 degrees. Which should be minus 60 first, get 120 minus 5, get 115. So this angle is 115 degrees inside here. And then now to find the alpha, gonna have to use sine rule. But the theta then becomes 360 minus the 115 and minus the alpha. That's what theta becomes, that red angle. Why is that? Because total angle around the point is 360. This part of it is 115, this part of it is alpha. So the theta that we want becomes equal to, I'll write it down here. This angle theta that we want becomes 360 minus the 115 and minus the alpha. We're going to use sine rule for the alpha. So that's the calculation we're going to use. Let's put the sine rule for alpha right down here so now. Quick and fast. So sine rule for alpha. To find this alpha, we're going to use sine rule. So sine rule for the alpha. Alright. I'm going to say sine of alpha over the side opposite the alpha is 180 equals sine of the angle that you know, which is 83, over the side opposite to it is the 290 290. Then to make alpha the subject, I'm going to take the 180, multiply it up here, and then take the inverse sign. So the alpha is going to be sine to the minus 1 of 180 comes up here. So I'm going to get 180 times 180 times sine of 83 degrees divided by the 290. And that's going to give us the alpha that we want to put here. I'm going to get the calculator and work this out. So I'm working out sine to the minus 1 of a fraction on the top of 180 times sine of 83 over 290. That's 38 degrees, 38.0. So the bearing then becomes theta equals 360 minus 115 minus 38 degrees. Let's write this better. 115 degrees minus 38 degrees. So the bearing angle theta becomes equal to 360 minus 115 minus 38, 207. That is it, 207 degrees. So I leave all these work on my paper and just put the answer down here. Alright, let's put my answer down here. Is theta, which is 360 minus 115 minus alpha, which is 360, minus 115 minus 38, which then is 207 degrees. And that is it. And I'm leaving somebody's work scenario and so on my diagram as part of the solution. I'm leaving these on my diagram as part of the solution. And that ends that question, guys. Are they okay?
Yes, sir.
Solid. So we did 3 nice questions. Practice some bearings and practice some circular theory. Alright, then get to do a circular measure, but don't worry, all of that will come. Because all these papers, we're gonna do them all over again. We're gonna encounter everything. But that is it for today. I'd advise you to go and redo the questions. Alright, and I'll see you tomorrow. Tomorrow, I think we're doing plane and solid geometry. Starting a new topic tomorrow. Plane and solid geometry. So see you then, guys. See you in class. Alright, bye. Bye, everybody.
Yes, sir.